Hello and welcome to my channel Flexomaster, and today we are going to learn and I will teach you the new chapter number 4, which is on plastic films in packaging, which will cover linear low density polyethylene, low density polyethylene, polyethylene terephthalate, PET, high density polyethylene, polypropylene, polyvinyl chloride, nylon, polystyrene, etc. So what is important in this topic, that the packaging will cover the subject in this video. So packaging film is very thin plastic and the basic component of plastic and elastomers materials is polymer. This chapter is narrowly focused on the commercial plastic films used in packaging. Generally, films are used as barriers. They keep dirt, germs, liquids, or gases on one side of the film. Nearly any plastic can be made in film form, but this chapter will discuss only those they are used for packaging on a commercial basis. So, by definition, flexible packaging includes bags, envelopes, pouches, sachets, and wraps made of easily yielding materials such as film, foil, or paper sheeting, which, when filled and sealed, acquires flexible shape. This chapter also will not cover multilayer films, which are commercially very important but covered in another chapter. A trend toward conversion to biodegradable, sustainable, and recyclable flexible packaging materials to improve the environment footprint of packaging. Flexible packaging films being made thinner to reduce cost and minimize waste after use, which also drives the need for higher performing materials. Flexible packaging products will replace bottles and containers for a range of food beverages products. Now, first we will start with the polyethylene. What is that? So there are several types of polyethylene which are classified mostly by their density. There are several ASTM standards. They are used to describe polyethylene, including ASTM D210310 standard specification for polyethylene film and sheeting. According to the ASTM D124812 standard specification for polyethylene plastic extrusion material for wire and cable, the basic types or classification of polyethylene are as follows. Number one, ultra low density polyethylene polymers with densities ranging from 0.89 to 0.905 grams per centimeter cube contains comonomer. Very low density polyethylene, which is polymer with density ranging from 0.905 to 0.915 grams per centimeter cube, contains co-monomer. Linear low density polyethylene, LLDPE, which is contains density ranging from 0.915 to 0.935 grams per centimeter cube, contains co-monomer. Now, LDPE, which is low density polyethylene polymers with density ranging from about 0.915 to 0.935 grams per centimeter cube. Further specification, ASTM D, this is the standard of D46350A standard specification for polyethylene films made from low density polyethylene for general use and packaging applications. Medium density polyethylene, which is polymers with density ranging from 0.926 to 0.940 grams per centimeter cube, may or may not contain co-monomer. Further specifications, ASTM D398109A standard specification for polyethylene films made from medium density polyethylene for general use and packaging applications. High density, which is HDPE polymers with density ranging from 0.940 to 0.970 grams per centimeter cube, may or may not contain comonomers. These applications for polyethylene including ULDPE, which can make heavy duty sacks, turf bags, coal consumer bags, packaging for cheese, meat, coffee and detergent, silage wrap, and mulch films and extruded membranes. LDP, food packaging, bread bags, baked goods, light duty produce bags, etc. Light to heavy duty bags, textile packaging, shirts, sweaters, etc. LLDP, agriculture films, saran wrap and bubble wrap. MDP, specialty merchandise bags, mailing envelopes, heavy duty shipping sacks, pallet shrink films, fresh cut produce packaging. HDP, food packaging, dairy products and bottled water, cosmetic material, medical products and household chemicals. What is ASTM D2103, which is the standard? This specification covers the classification of polyethylene film and sheeting up to 0.3 millimeter and in thickness inclusive. This film or sheeting may contain additives for the improvement of surface properties, pigments or stabilizer or combinations thereof. Polypropylene. Polypropylene can be made in a number of ways. The way it is produced can affect its physical properties. It can also have very small amounts of comonomers which will alter its structure and property. The three main types of polypropylene generally available. Number one, homopolymers are made in a single reactor with propylene and catalyst. It is the stiffest of the three propylene types, has the highest tensile strength at yield. In the natural state, no colorant added. It is translucent and has excellent see-through or contact clarity with liquids. In comparison to other two types of it, has less impact resistance, especially below 0 degree centigrade. Random copolymer, homophasic copolymer is made in a single reactor with a small amount of ethylene 0.5% added, which disrupts the crystallinity of the polymer, allowing this type of its clearest. It is also the most flexible with the lowest tensile strength of the three. It has better room temperature impact than homopolymers, but shares the same relative poor impact resistance at low temperature. Number three, impact copolymers, that is called heterophasic copolymer, also known as block copolymers, are made in a two reactors system in which the homopolymer matrix is made in the first reactor and then transferred to the second reactor, where ethylene and polypropylene and polymerized to create ethylene propylene rubber in form of microscopic nodules dispersed in the homopolymer matrix phase. These nodules impart impact resistance at both ambient and low temperatures to the compound. This type has intermediate stiffness and tensile strength, and it is quietly cloud. In general, the more ethylene monomers is added, the greater the impact resistance with correspondingly lower stiffness and tensile strength. Application of the polypropylene. Application and uses of polypropylene include homopolymer, thermoforming, its use in thermoforming, slit film and oriented fibers, random copolymer, food, household chemicals, beauty aid products, clear containers, and hot fill application. Impact copolymers, film, sheet, and profiles. And these are the standards used in for polypropylene films. All right. Here, polyester now. Polyester is terephthalate, PET, is the most common thermoplastic polyester packaging film and is often called just polyester. PET exists both as an amorphous, transparent, and as a semi-crystalline, opaque and white thermoplastic material. Semi-crystalline PET has good strength, ductility, stiffness, and hardness. Amorphous PET has better ductility but less stiffness and hardness. It absorbs very little water. And application and uses. PET plastic is a strong, clear plastic commonly used for food packaging, plastic bottles, household containers, roasting bags, audio video tapes, release liner. stamping foils, and label overlay. PET as a packaging material. PET is a colorless transparent polymer that is almost unbreakable, can be recycled. Well, these good properties led to broad distribution of PET as a packaging material for beverages. By contrast, and beverages cans or cartons, the transparency allows the beverage to be seen. The unbreakable nature of PET is an advantage over glass bottles. Moreover, PET is distinctly lighter than glass. Here you can see the preforms and PET bottles. Specialty polyester. While PET is by far most common polyester packaging film, there are many other polyester also offered. These specialty films are described in the following section. Number A, polyethylene naphthalate. Polyethylene naphthalate pen is similar to PET but has better temperature resistance, strength, hydrolysis resistance, dimensional stability, and low oligomer extraction. It is particularly stable when exposed to sterilization process. Significant commercial markets have been developed for its application in textile and industrial fibers, films, and foamed articles, containers or carbonated beverages, water and other liquids, and thermoform application. Number B, liquid crystalline polymers are high performance specialty films. Uh, Films and sheets are well suited for many medical, chemical, electronic, beverage, and food packaging applications. They are more impermeable to water vapor, oxygen, carbon dioxide, and other gases than typical barrier resins when LCP is diaxially oriented. It forms a high-strength material with relatively uniform properties and low fibrillation. Also, its high temperature capability enables to meet the needs of a thermally demanding applications such as film for printed wiring boards. Number C, polybutylene terephthalate. And this is a material is semi-crystalline white or off-white polyester, similarly in both compositions and properties to PET. It has somewhat lower strength and stiffness than PET. Is a little softer but has higher impact strength and similar chemical resistance. As it crystallizes more rapidly than PET, it tends to be preferred for industrial scale molding. It is a dimensionally stable sterilized film with good optical quality even after sterilization. Now come to polycarbonate. PC is another polyester film. Polycarbonate performance properties including very impact resistance and is virtually unbreakable and remains tough as low temperature, clear or glass clarity, high heat resistance, dimensional stability, resistance to ultraviolet light, allowing exterior use, flame retardant. This film offers high heat resistant and superior dimensional stability and finds used in packaging of medical devices. Here the figure showing there are many applications for polycarbonate, which is aeroplane windows, suitcases, automobile interior and exteriors, medical equipment, dyes laser, three-way stopcocks, lenses for glasses and sunglasses, game consoles, roofing and fences. Now come to polyvinyl chloride, which is we are calling in PVC, is a flexible or rigid material that is chemically non-reactive. Rigid PVC is easily machined, heat formed, welded, and even solvent cemented. PVC can also be machined using standard metal working tools and finished to close tolerances and finish without great difficulty. PVC resins are normally mixed with the other additives such as impact modifiers and stabilizers, providing hundreds of PVC-based materials with a variety of engineering properties. There are three broadest classification for rigid PVC compounds, type A, type 2 and CPVC. Type 2 differs from type A due to greater impact values but lower chemical resistance. CPVC has greater high temperature resistance. These materials are considered unplasticized because they are less flexible than the plasticide formulation. Application and uses. Now, PVC used packaging in packaging is a major market for PVC, and rigid gates are blown into bottles and made into sheets for thermoforming boxes and blister packs. This is a thermoforming box and blister packs here, which is containing the cakes. And flexible PVC compounds are used in food packaging application because of the strength, transparency, processability, and low raw material cost. And then polystyrene. Polystyrene is PS, we calling it PS, is the simplest plastic based on styrene. There are three general forms of polystyrene films: general purpose polystyrene, oriented polystyrene, high impact polystyrene. One of the most important plastic is high impact polystyrene, that is called HIPS also in short form. This is a PS matrix that is embedded with an impact modifier, which is basically a rubber-like polymer such as polybutadiene. The application here with the for general purpose here showing yogurt, cream, butter, meat trays, egg cartons, fruit and vegetables, as well as cakes, croissant and cookies. Medical and packaging disposable, bakery packaging, a large and small application, medical and packaging, particularly when where clarity is required, window envelope, patches and labels. Oriented PS films can be printed and laminated to the foams for food services, plates and trays, offering improved aesthetics. The films can also be used as a laminate to PS sheet for a high gloss shine for bakery convenience food items. So here we will close the chapter number 4, and we will go to our next chapter. Also is based on the plastic films and packaging, and we will continue also in the coming chapters to cover the full range of plastic films. And here I would like to thank all of you for seeing this video, and please comment what is required further to study more, and I'm going into a proper chapter wise syllabus, and which will be the basic now, and again in future, in coming future, you will find lot of technical, more deep technical teachings in flexography and printing and packaging. So thank you very much, and don't forget to comment, write your comments, and share and like and subscribe my channel. Thank you very much. Goodbye.